Reaction mechanisms: nucleophilic addition and nucleophilic acyl substitution. Chemistry 269, Jennifer Angelo, Hayden Garner, and Jake Sherrill.
To start off, we'll explain what is oxidation and reduction. Oxidation is a decrease in the number of carbon and hydrogen bonds. We see in the first compound that there's one bond to hydrogen here. We also have bonds on these carbons here and here. And in the following compound, we see a decrease in hydrogen bonds due to the oxygen bonding to the carbon instead of the hydrogen.
Next, we will explore what a reduction is. A reduction is an increase in the number of carbon-hydrogen bonds. In the original molecule, you will note that there is an oxygen bonded to the carbon. In the following molecule, you will note that that bond has been broken and has formed a new bond to a hydrogen here. One broken bond. This bond will break and be replaced with a hydrogen. To understand why nucleophilic addition and nucleophilic acyl substitution are different, we must first have some very important review that deals with good and bad leaving groups. Good leaving groups are molecular compositions that are comfortable on their own due to the pKa of the conjugate base. You will notice that Br is a good leaving group because it has a low pKa, -7 to -10. We will note that bad leaving groups contain H's and some R's, and they are molecular compositions that prefer to remain attached to the carbon in the original molecules. We notice that the pKa of hydrogen is much higher at a 35, while most R groups have a pKa of much closer to 50. R groups is an abbreviation for any group in which a carbon or hydrogen atom is attached to the rest of the molecule. Sometimes oxygens can be used within this group.
Of the two general mechanisms we're exploring in the video, first we see nucleophilic addition. Nucleophilic addition occurs when there are bad leaving groups such as H or R on a compound. Here we see that H is the bad leaving group. In the reaction, the nucleophile comes on and attaches to the carbon, pushing the bond away towards the oxygen. Rather than having the hydrogen leave, which is a bad leaving group, we see another compound come in and perform an addition to the oxygen.
This will neutralize the charge on the oxygen, resulting in a more stable compound.
The second mechanism we see is nucleophilic acyl substitution. Acyl simply means carbon. Nucleophilic acyl substitution occurs with good leaving groups such as these. In the reaction, we see that the nucleophile attaches to the carbon, much like in the previous mechanism, and then the bond is pushed over into the oxygen. What differs is we have a good leaving group, so rather than having another compound come in attached to the oxygen, we get the negative charge on the oxygen coming back down to reform a double bond, and the good leaving group going on by itself. So then we see the same compound, only with a nucleophile replacing the leaving group.
We will now look at some of the more useful reductions and oxidations of carbonyls. In the first example, the aldehyde or ketone can be reduced to an alcohol. In the second example, see a carboxyl group being reduced to an aldehyde or an alcohol. In both examples, this occurs by adding a proton to each starting molecule. In the third example, we will look at the oxidation of an aldehyde to a carboxylic acid. You can see the number of hydrogen bonds, carbon-hydrogen bonds, decreases when this molecule is oxidized from an aldehyde to a carboxylic acid. This occurs when the oxygen replaces the hydrogen bond right here.